Hello, this is the December 12th session of our grant program. This is the morning session. If you're watching this later. I'm Dr. Hyatt, if you haven't watched the first video. And this is our group in Odessa, Texas right now. You can't see, you can tell for me. It's like, and Dr. Kemp is joining us from Marfa, I believe it's Marfa. And the first thing we're going to do is watch a little video. I'm going to share a web tour with you if you're watching at home. So click on the link that shows up. Okay, so I'm going to turn off the talk on our side.
Can anybody
play this video for our group?
Hey, can you hear us?
Yes, I can hear you.
Great. Here's our group. Everybody wave.
Hello.
We have more this time.
Oh, let me switch to your video.
We got a whole bunch of people. I got to figure out how to make the video big on this end. Now I don't know what happened there. Let me turn off the talkie.
I actually took off your video permission, but I give it back to you. Sorry.
Okay, just to make sure, because I forgot how all this works. I got to figure out how to make the video full screen. And so, you know, look at them, don't look at me. Let's see, how do I make the video full screen? Okay, I don't have any idea how to do this, so maybe we'll just there, I'll turn off our video.
I tried to make the video follow the speaker, but even when my talk is turned off, it's still not defaulting to you.
Oh, it'll go back to me. I turned off our video for the moment just because I don't want it to randomly come on. I was going to go ahead and show the video here. I was just going to remind you to mute your mic on that end when you show the video.
All right, I will mute my mic right now to show the video.
Okay, cool. So, okay, we're still not getting sound on this. So, let me go through and just quickly look at the sound settings. You know, a month ago I didn't have any problems with any of this. We just walked in and it just all worked like magic. It was so cool. Sound recording, sound playback, IDT, audio, everything is set at top level. USB audio device, hardware, voice, default playback, IDT audio, volumes are all set to high. Okay. Okay, this is not going to be good. Let's see, I don't have anything plugged in here. It should be coming out of here right now, and I unplugged it because I thought maybe it was the connection there, but I'm not getting any sound coming out of the speakers. And when I look at my audio settings, everything is set to maximum. And we could hear them, so yes, that's fine. The video. No, I've played the video before, but let's try to play it from his link. For YouTube, which we ran into some trouble last time, so. Let's see. If this video isn't available. I downloaded it, and I have it, and it played perfectly yesterday. So, let's see. Let me open that with something else. Open with. Let's try to play. We just finished our video. It sounds like we can hear you talking, so it sounds like you're still trying to get yours played. Is that true? Yes, I'm sorry. I forgot to turn off the microphone. We're just trying to get sound, and so give me 5 minutes to work with this real quick and see if I can make it work. Okay, the problem is I'm not getting any sound on any of the videos that I am running, and so we'll try to do something different. Maybe I'll put them on a flash drive and try them on a different computer. And anyway, I'm going to turn off the talk, and we'll just go with what you're doing right now. All right. I don't think the sound's that important on the activity video anyway, so maybe you can show them at lunch or something. Okay, so the first activity we're going to do is another one of those 3 acts that we did. Like last time we did the one with the falling rock, right? So I'm going to show you a video, and I want to know what questions it makes you think of. So let's watch that video, which I'm going to share the link as well. If you're watching at home, think about what questions you would ask when watching this video. Let me post it in the chat box as well. Okay, so we're going to watch this video. Think about what questions it makes you think of. So let's. Okay, so we're going to move to the board. And if you're watching at home, be writing down some of your ideas of questions that you have. First. All right, so what questions does that make you think of?
Is the percent about that? Sorry if I misspell words. I tend to do that regularly, so you're welcome to correct my spelling if you want. But any other? Do what? How do they measure change? Any other questions?
How does nature affect his life perception of God? Because the causes of your thought, you know, you know, like on the earth, and the size of it's pretty small compared to the cause.
So does the change affect the size of objects?
The size perception.
Size perception of objects?
You know, when if you're trying to calculate distance.
Any other questions? Wait, that video makes you think that? So what, I mean, if both are on, is 100% in? So really, the first and last question, you could maybe sum it up as one question as what? What? What effect does it produce? Right? But what are you really asking in the first and the fourth question? What are you asking? Okay. So what question? If you saw it down in the bottom and said 50% 10, what question do you really want to know then? The total fit, or what percentage when both sunglasses are on, right? I mean, that's really what you asked. It's just, I want to write it maybe a little more clear. What is the tint with both glasses? Which I think that's what you were asking anyway.
My question is it kind of like probability like the using and I know it's not logical that it could be 50 or 70%.
You add 10 or multiply. Okay, so I think we have some questions. So the one I really want you to focus on then is these ones that are all related to each other here. So at your table, I'll give you, say, 3 minutes to think about answering that question. I'll give you 3 minutes. And did your group have any other questions, Lauren? And if you're watching this at home, take about 3 minutes to try and answer these questions. At least, actually, I'll give you 5 minutes, and I'll ask the questions in this way. What is the tint with both glasses on? And then give a guess and a guess that is obviously too high. And a guess that is obviously too low. So I want your table to give a guess on what they think what you think the tint is both sides on, and give a guess that you think is definitely too high, and a guess you think is definitely too low. So 3 guesses. And I'll give you 3 minutes from now. And if in answering the questions you need to figure out what the definition of tint is, then figure it out and you can share it with us. Yeah, you can go home.
Okay, we're back, but I had you muted this whole time because we were trying to catch up with the videos. So I see the timer on. What are we doing at this point? Maybe he's got us. Three minutes from now to answer 3 questions. So what 3 questions are we answering? That I can guess. Dan Meyer's 3-act map, which is where he's getting this thing. Double sunglasses. So here's the website that this video is on. So you guessed 50%. What do you think your students would guess?
Okay, so let's go to these questions. So let's see. Okay, so each table, including, and then also Lauren, your tables, however many tables you have, and Martha can give us a guess. Your guess, a guess that you think is too high for sure, a guess you think is too low for sure. So first of all, let's go with the guesses. So starting here, what's your guess?
We get 75%.
75%. 75%. 25%. What? 25%. 60%. Here. 70%. And the left table. 75. Okay, then I guess that's definitely too high. I guess we'll start with that and then work my way back around. 150. Next table. 150. So 2 at 150% apparently. 75 is definitely too high. Okay.
0%.
Huh?
0%.
Is too high? All right. Next. Over here. 100%.
We want to raise your with 101.
101%.
Now.
Infinity plus 1, right? Okay, so then don't just wait too low. 50. 30. Back here. 20. And 0. Okay, so we actually have a pretty wide range of guesses. Let's see what the group in Marfa has guessed. Let me see first. Warren, were you guys able to make some guesses?
We're kind of curious on this end what the rationale is for some of these guesses, what we anticipate the thinking would be behind them. Are we just throwing out random numbers, or the consensus here at the beginning was 75% would be filtered, but that and all of the students would figure either 60% or 100%.
No, I couldn't. Let me turn off my microphone. Maybe that'll help.
Okay, the consensus here on the first question, can you hear us now?
Yes, I can hear you now.
Okay, well, everybody pretty much immediately agreed it would be 75% filtered, and then when we thought about what students would think, the answers that came back were around 60% or 100%, thinking that doing it twice would get rid of all the light. And we were curious as to what some of these other guesses, if they were actually motivated by particular lines of thinking, or if they're just kind of random guesses that are just numbers that we know are too big or too low.
Well, I will ask them. So, so they get 75%. He said pretty across the board, and that's actually the main group of ours gets 75. A couple were pretty close. Who gets 25%? What was your motivation for 25%?
Out here, as one of the numbers that we started, that's the percent black most in the land. So 25% that we started is 25. So we said too high the 0% is completely black. No,
Yeah, 50% of the white on the first.
Is that a definition that you looked up, or? So the percent of tint is how much light is coming through. So 100% tint is completely no tint at all. I don't think that's the definition that he was using on these videos. But so your guess with what his definition was, your guess would have been 75% then. Because you're saying that 25% means 75% of the light is blocked.
through the video, yes.
Yeah.
Actually, you know, you would think.
Right, and I.
That's a little that's
so I think his definition that he used was the percent was how much was blocked, not how much was let through. So it's opposite of what you guys said. So that makes sense then, right? So that's why you said 0% is too high, because that means it completely blocks everything. So it's 0% let through, not 0% blocked. Which, if you watch the answer, this video is the percent blocked is what he used as a definition. So it's the exact opposite of what you're doing. Okay, so Lauren, did you guys hear that they're using the actual definition of tint, not the one that Dan Meyer used on the video? And the actual definition apparently is the percent tint is how much light is let through. So 0% tint is completely blocked light. And it was even stated on vehicle tinting that 5% tint is the darkest you can buy, because it's pretty much black, I guess, at that point.
Because they did, we got a tint on automobile is different from tint on the glasses. There's basically 30, 10, 50, and 80, and 10% allows 10% of the, it blocks 10% of the light.
Okay.
50% blocks 50% of light, 80% blocks 80% of the light.
Okay, and that's what he was using in the video. So I guess vehicle tinting is opposite of sunglass tinting, I guess. Definition.
Well, I just looked at
According to ophthalmologist's website.
from Florida.
And then in Florida. And he left some hanging tattoo when he was there. All right, so did you hear us on some people use the definition of tint for vehicles, and some people use the definition of tint for sunglasses, and that's why the answers were kind of opposite. Who gets 60%? What was your reasoning behind 60%?
I didn't think that it was completely cumulative, like 50 plus 50, but I thought it might have only more. They had completely different. Not very scientific.
So it really was a guess.
Yeah.
But a somewhat educated guess that it should block more than one pair of sunglasses, but you didn't think it was going to be a lot. Makes sense. And so then these were obviously using this. What was your guys' guess that was too low? Was it 50? So these all were using that definition that this is the amount of light let through, not the amount of light blocked. Yeah, so if you did the opposite, this would be 75, would be the same place. this would be 100 right here, and this would be 50. And maybe that's why you use 50, because you can't tell which way it's going, right? So, okay, so these are our guesses. So let's see what the answer video shows. The real activity I want to do is the follow-up activity, which is, I think, a little more interesting. Let's see. I need to. Okay, if you've been talking, Lauren, I haven't been able to hear you in a little while. So did you all get the explanations that some people use different definitions of tinting?
We got that, yeah. And had a little discussion on it here too, but I just didn't keep the talk link on.
All right, I just want to make sure. So I'm going to show the second or the conclusion video for this particular part before we move on to the last activity for this part. So let's show the conclusion video. So this, I guess I can just lost it. If you're watching this at home, watch either the link I put in the chat window or the link that showed up on the follow page, and we'll watch the video here. I'm going to turn off the talk button so you don't have to hear our sound. Okay, so if you see that the answer was in fact 75%. So now I want to move on to the final question about this tinting, the sunglasses tinting. Let me pull it up. This. Okay, so the final video that we're going to watch is going to lead to hopefully another question. So let's watch this last video. And if you're at home, think about what question is being asked in this video. So I'm going to turn off our talk so we can watch this video ourselves. All right, so we just watched that video. Were you able to finish watching the third video on your end? I haven't heard any response, so I'm hoping that you were able to watch that third video on with the 5% tints in it. But I'm going to go to the.
So yes, we were able to watch that video, and we're starting to work on trying to figure out figure it out.
All right, well, we're going to go to the writing space. So what question does that ask?
That's 5% really add 5%.
So one question you could ask is, does 5% really add 5%? All right. What's another question that's asked by this video? How many 5% tins do you have to use to get to 60% tins? Or I guess, how many 95% tins do you have to use to get to 40% tin, right? Same definition. Okay, so how many 5% tins do you have to overlay before you get to 60% tin? So I want you to think about that question in your tables. We're going to move around tables in a minute, but in this activity we can say where we're at. So think about answering that question. I'm going to give you say 15 minutes to really think about answering that question, coming up with an answer that you would want to share with the group. So how many 5% tins get to 60% tins? If you're watching at home, I'm going to give a 15-minute timer. So think about your answers. Okay, so what guesses did you have? Or I guess, how did you work? What was your answer that you got? 10? We got 10. We got 23. Another 23.
We got 1,979, 1,909. We can't move around.
1,979 to 1,990. I know, it's
We had 7 was just under 50%, 8 was well over. That's
the 8. So I have 1, 2, 3, 4, 5. So 2 more tables that haven't given us their answer yet. Who are they? What 2 tables have not given us an answer? So what?
Like at first we were thinking linearly and that's how we got 23. But then we were like, we're one thing. Like when you said left, you start with 1. And then if you're blocking 5% of the light and you still have 95% of the light there, then you take 5% of that, and now you have, we're working out, you have, you keep blocking 5% of the light, it's more than half the time you're blocking.
Did anyone else have it?
Yeah, we did 10.
Anyone else? So those these back tables, didn't have an answer at all? Warren, what answers did we get in Warren's class?
Oh, I typed them into the comments there. The first guess was around 12 because 12 times 5 was 60. Other guesses included 10, 18. 18 turned out to be what everybody agreed upon based on actually doing computations and using the definition in the video.
Okay, so you had 3 guesses, but 1 was based on computation. So we had 10, 12, and 18 based on computation. Okay, so how would you go about calculating this? So do I have a volunteer to calculate this on our emulator here of a TIE4? You can calculate it however you calculated it. Any volunteers? Anyone want to use the TIE4? Anybody? No one wants to volunteer? You have to come up to this nice big board. Or does anyone want to suggest how you could go about doing it on the calculator? I think they're working on it. How are you guys working on it right now?
I'm not sure the way to write the formula because if there was a crazy number, so I'm actually getting close to that. Actually, yeah, they're really about that. Because I'm not that many, and I'm not a huge one, so we just have 5% of the air between.
How did you go about doing that?
Well, if you block 5% of the light, then you're letting in 95%.
Okay.
So you 95%, 95 as a regular number.
All right, so 95.
Figure 95%, and then multiply that times 5% of that number.
How did you? So you multiply it by 0.05?
we're subtracting that much light into the next 10. So we put 95 minus 2.75.
So is there a different way you could possibly do that? So instead of multiplying by 0.05 to get the subtraction, just multiply by 29. If you want 95%, that's 0.9. So instead of going through two processes, right? So 95 times 0.95 gives you the same thing, right? So 100 times 0.95 to the x power was the suggestion. We start with 100% visibility, and you multiply that by the exponential function 0.95 to the x, it's going to graph what's going on, right? And what's your target? 40, exactly. Because by the definition, now of course, if you had used the definition that was given on, for tinting cars, then you could have said 60 was your target, but you would be multiplying by not by 0.95, but by what? 0.05, exactly. So if we graph this, nothing to open window probably because our windows. So we need to change the window to what would be reasonable. Well, if you multiply 100 by 95%, then you're right. This definition was using the other method, right? But to set it up to work with the definition on, it's easier to work with the car definition and just think backwards. Because if you think about it, you're going to be taking 0% and adding something to it rather than just, so you would have to start with 0, which doesn't matter, and you would somehow have to add 5% every time, set up kind of like your subtraction problem, right? So it's kind of hard to graph something like that. So what window do we need, though? If we started out with our function as 100 times 0.95 x to the x, what window do we need? What y values do we have to go between? If you plug in 0 to this, what do you get? 100. So you definitely have to go up to 100 on your y values, right? So if in our window, we definitely need to go up to 100 in our y values, and our max right now is 10, so we're not going to see anything on that, right? What about our minimum? Can we ever get to negative percent tenths? So 0 seems reasonable, right? What about our x values? Are we going to get minus 10 5% tenths? So 0 seems reasonable. And then if you look at our guesses, the biggest guess was, the biggest guess was really big, but the biggest small guess was 23. So if we go somewhere a little bit over that, maybe 30 or something, see if we're right. So if you notice, this is our target, 40% light let through, which is 60% tint, right? So this is 40% of the light let through, or 60% tint on sunglasses tint. This is the function that removes 5% of the light every time you go up another integer, right? So the intersection is going to tell us how many 5% tints that we have to go through. So we can actually calculate that by going into, 60% tint is 40% of the light let in. Right? So this is 40. This is the amount of light let in, right? Because you start at 100% of the light let in, you remove 5% of the light let in every time. So the function itself if we were doing it that way, our function should go up, right? So if we were going to do the sunglass tint method, we would need a function that increases up to 60, right? So, but it's actually, first of all, it was suggested by someone to use this function, so I'm going to use it anyways. This is the function I use myself, but we can think about what function we'd have to use to do the other definition. We'll do that in a second. But if we calculate the intersection on our calculator, right, if you go to second, calculate and intersection, and pick the two functions, we get 17.863753 is how many 5% tints are needed to go to 60% tints, or 40% of the light let in. So one of the things that might have happened was that you got to 60 and you thought you were done. But if you use this function, this is the backwards definition, right? So let's think about, if you had gone to 60 instead of, maybe that's where the 10 came in. So if you had gone to 60 and calculated the intersection, then you would have got an answer close to 10, 9.958. So but that's 60% of the light let through, so that's only 40% tints, right? So, and that's probably where the two different guesses of 10 and 18 came from, right? Because one was targeting this multiplying or removing 5% every time and getting down to 60, but that's not, that's the backwards of the definition, right? So let me see. Warren, can you take over with your emulator on our board? Because maybe your group can use a different function to come up with the opposite way to come up with the same thing. So starting at 0 and going up to 60% tint instead of starting.
Okay, you'll have to give me a cursor control.
How do I do that?
Well, I'm pushing a button here that says request cursor control.
We want it to flow 60%. Yes, so allow you 40%.
Let's see.
It just said I gave you control of shared applications. Is that what I need to do?
Yeah. Let's see. So stop sharing. Let me see. Start sharing. Okay, so here's actually the discussion that was going on down here has started with, can you see my calculator?
Yes, we can see your calculator. I'm going to turn my toggle off so you don't get mixed sound, but we can see your calculator.
Okay. So you illustrated the graphical approach to doing this. There were the more natural thing that seemed, or more thing that students were maybe more likely to do, which I think you started out with, was sort of a trial and error thing. So looking at the idea of just taking 0.95 times the 100, and then of course multiplying, doing that again. Well, let's see. So times 0.95, and so that would be twice, and then 3 times, and 4 times, and 5 times, and just doing it until you actually, by trial and error, get down to 60. And so there was agreement here that that would be a place students might try. A slightly more sophisticated approach with the students would have been to have the calculator do it, to set up a table and do it. So I've used the second table set, which is right above the window command. And by default, your table goes up in increments of 1. And so there you can just, it's pretty much the same approach. You just scroll down in the table until you reach the level of 40% transmission. And so that goes down, and as you know, it gets down between 17 and 18. A more sophisticated thing to do with the table, actually going back to table set, is to combine the two approaches by setting it where you can put in the independent variable. And so then you might guess, initially we guessed 12, and we see that that gives a transmission of 54.036%. And so we figure out, oh, we're trying to get to where 60% of the light's filtered, and so that means only 40% would be left, so we might try 20 as a guess. Well, that's too much, and so 15 might be a good guess. Well, 15 was almost there. 16 is not quite there. 17 gives you just over 40%, and then 18 should give you just under 40% transmission. And so whether you need 18 actual filters to get below 40, or to get at least 60% of the light filtered. So to get below a 40% transmission. And then what was the other one? Oh, to solve it algebraically. And so looking at, let's see, let me stop that sharing and start sharing again, and this time share, let me just share the desktop. And so looking at, finally, and everybody seems to kind of think this would be about the last thing that students would actually do, that everything else would come first, right? Is that, because I think the discussion here was around, they'd first do it by sort of just plugging in the numbers and trying it out. The more sophisticated students might move to the table. You have the graphical way that we did it, and maybe the very last and maybe most unnatural thing would take this function, 100 times 0.95 to the x, and set that equal to 40, right? You want 40% of the light transmitted, and actually do that algebraically. So 0.95 times x would be 40 over 100, which is 2/5, and so x times the natural log of 0.95 would be 2/5, and so x would be 2/5 divided by the natural log of 0.95. So is that, and that's a much more sophisticated thing, right? You have to know about logarithms, you have to understand inverse functions. So by, before Algebra 2, you're probably not going to see that.
For Algebra 2 parts, I mean, that's Algebra 1. If you go this route. For Algebra 1 is
So Algebra 1 students could do this or not?
No. Algebra 2 students could.
Okay, so the agreement here is you're looking at students at least with the sophistication of Algebra 2 to take this algebraic solution. Other thoughts for the good of the order before I turn off the talk?
Regarding the computation, because in the law of length also.
Oh, yeah. I've been caught in an error, and so there. Now, for posterity, that will be recorded correctly, which is important. So I will give control back over to you.
All right, thank you. So we were talking about, possibly using a different function to get at our definition, right? Because our tint definition starts at 5%, and then if you add 5%, how do you add 5% tint to 5% tint? What do you get to? So if you multiply this by 1.05, so let's say 5, and what's 1.05 times 5? Well, I guess we can do it on the calculator. So we can go back to, so 1.05 times 5. So does that give us two 5% tints? So 5.25% tint is two 5% tints? But what percent tint? If you have two 5% tints layered, what's the percent tint? So remember when we had 50% tint and we put 50% tint over it, we got 75% tint, right? How did we do that? $10.25. Is that right? Which would be 5.25 plus 5. If your group wants to chime in on this, Warren, you're welcome to. Because they were bothered. Some of the people in our group were bothered by using a function that's not giving you directly the definition of the sunglasses tint. It's giving you the amount of light let through, not the amount of light blocked. So they wanted to think about using a different function that would give you the amount of light blocked, not the amount of light let through, right? Because the function that we did was 5% tint is 95% of light let through. That's where we got the 0.95 from, right? And then we take off another 5%, we have 0.95 squared. We can think about that we just did, right? If we have 0.95 squared minus 1, it should be 9.75% tint, right? How do we get to that?
1.95 times 5.
So you take 5, instead of times 1.05, you take it times 0.95, right? And add it to 5. Right? So if you take 95% of 5 and add it to 5, you get to the tint of 2 5% tints overlaid. What's 3 5% tints overlaid? What percent tint is that? It's 5% of which? Of the 4.75, right? So 4.75 times 0.95 plus 9.75. So you can see it's an unnatural way to set up a function, right? Because you're really having to go back to the other definition and then modify it back to the definition of the sunglasses. Maybe that's why they use this definition for cars. I don't know. It seems a lot easier to overlay. Right? So 35% tint is 14.2625% tint, right? Yes. How would you get to 3 overlaid?
The third tint, so take 5%
So let's see, 0.95 cubed minus 1 is 14.2625. So if you're using the other definition, if you do 0.95 cubed, which was the one definition we're using, if you do 3 5% tenths overlaid, you're letting through 85.75% of the light, which means you're blocking 14.2625% of the light, which that's the tenth number, right? So
I was still thinking about the light block.
yeah, see, that's why it's very unnatural to set up a function to try and do that. Right? So you can see it's a lot simpler the way our numbers work to take 95% of what you had rather than add 5% more out through, right, than what you had before. It's kind of like, you know, the way that we did it is kind of like coupons, right? If you have 50% coupon and a 50% off coupon, you have 75% off, right? So it's not, you're not thinking I have to pay 25%. You're thinking I have 75% off. It's a lot easier to think about how much you take off than it is how much you still have to pay. Yes.
The assumption that you need to have, are we going to do it, or use the 95% of that our calculation?
Yeah, you would have to. So what would the function be?
It would be 1 minus 0.97 to the next one.
Let's see. So instead of this, it would be 1 minus 0.95 to the x stuff. Exactly. Or times 100 if you want to. So, because originally I did with decimals, but you guys started with actual percent numbers. So it's not that much harder. It's just you have to really think about it, right? So you could use this function instead, and then your target instead of being 40 would be 60, right? Because this is going up now, right? Because you're taking off less and less, right? So if we plug that function in to our calculator, which is 100 times 1 minus 0.95 to the x. Oops. Delete. Okay, enter, and then we're targeting now 60% tint. We want to set our window to make sense, so starting at 0 to 100, starting at 0, and we said our answer was like 18, so if we do 30 again, that should be reasonable, right? Oops. Did I not fix the window? Oh, I did backwards, right? The x should go from 0 to 30, and the y should go from 0. So that was my fault, right?
Oh, yeah.
Because you'll get over 30% tint pretty fast, so that's what was happening. So if you notice, this is what it would look like if you were thinking about the actual definition of sunglasses tint, rather than the car tinting definition, which is, to me, more natural to set up a function for, right? And you still get the same answer, right? Because if you look, you have this table here, plus, so let's go to the table. Where's the table? There it is. So if you look at the table and you just follow it down, you should get to between 17 and 18 again to get to the 60% tint now. So this now is the percent tint, not the amount of light blocked, right? So, but this is really, I think this is a really good activity because you can hit a wide range of ability levels. You can work with tables, you can work with intersecting graphs, you can work with pre-calculus, you can do calculus stuff if you want to. With this one activity, you can really make it narrow or broad depending on where you're at, right? And you guys are all high school teachers, so you teach a pretty wide range of subjects and things. And, you know, if you're just talking about percentages, you could do this too. You can go down and up quite a bit with this problem. Okay, so let's move on to our algebraic, fostering algebraic thinking activities. In fact, let's take a 5-minute break. So we'll come back in 5 minutes. We'll set an alarm. So we're going to take a 5-minute break on this side, Lauren, and I'm going to set a 5-minute alarm. So for anyone watching this video at home, for the last activity, I'd like you to write up at least some description on how you solved your guesses, how you solved the problem, both the sunglasses problem with the 2 double sunglasses and the 5% tint problem, and post them onto our Facebook page. Which, to get to the Facebook page, you just type in West Texas Mathematics Consortium. So this is our Facebook page where you can post. You can do one post for the entire thing, but inside the post, at least I want your answers, your guesses for both the 2 sunglasses overlapping and the 5% tint problem. So, and just compile it, and at the end of watching all of the videos for today, you can post it all together in one post. Okay, so we're going to begin again. So now we're going to look at the fostering algebraic thinking. So remember, last time you did. Last time you did an activity called crossing the river, right? So just as a refresher of what that activity is. Let me. So if you remember the crossing the river problem, they're saying the crossing the river was free from the book. Yeah, really, the book is a supplement to the activities that we do. It's kind of more of the thinking process behind it rather than actual activities and such. So, but you did crossing the river, right? So you had this problem where 8 adults and 2 children, you could cross the river and have small boats, and the boat can hold either 1 adult or 2 children. Everyone can row the boat. You have to get across, right? And so remember, last time I also said that by the March meeting, or is it February meeting or March? The February meeting is supposed to bring student work, right? So today we're going to look at sample student work from this material. It's actually student work, but it's not your student. So eventually in February we're going to look at your own student work and look at how they think about stuff. But I'm going to pass out some example papers, but I wanted to remind you what the problem was, right? And you're going to see solutions to the problem. You might not remember it much later what the problem was, or you might not have been there. So, what we're going to do And if you're watching at home, I'm going to go through this. That's not what I wanted. This. Okay. I'm going to look at this activity. So we're going to break into small groups of 2 to 4 people. If you're by yourself at home, obviously you're a group of 1 people. In your small groups, discuss the questions below which relate to examples of student work found directly behind the discussion questions. So I'm going to pass them out. I'll also project them up for the people watching at home. So these are the discussion questions that you're going to want to think about. So you're going to look over Student D's example paper, which I'll pass out in a second, and discuss how the teacher, in this case, analyzed Student D's work. Look over the other 3 examples papers, Students A, B, and C, which I'll also pass out by yourself, and go through each paper and jot down on a blank student work analysis sheet, which I'll also pass out, what you noticed, some few things that you notice about those papers, and what you infer from the features you noted, and alternative references from each student's algebraic thinking as reflected in the work. And then rejoin your small group and briefly share some of what you wrote on the student analysis sheet. And then there's a couple more questions. So what differences you see and how they build the rules. And then part 4, describe the differences and how they represent the problem. Right? So this is the activity. And I'm going to set a timer for, how long do they want for this one? 40 minutes. So you have plenty of time to look through these. You're going to have 4 different examples of student work. And I guess okay, so we've got the stuff I'm going to pass down in a minute. Okay, so I'm going to. So if you're watching at home, I'm going to slowly go through the student's work, so you can pause at any time and look at the student work yourself, since you don't have a copy of it. I'm also going to I need to post these on either a Drive, Google Drive, and share it or something like that. So let's set a timer here. I'm going to set a timer for 45 minutes because it'll probably take me 5 minutes to pass all this stuff out and set everything up. So set a timer for 45 minutes. Okay, and so this. We're going to have a timer going. We're going to have a timer going like this. Okay, so let's go back. Let's do this and share. Okay, so. And this is something to keep in mind. Remember the algebraic habits of mind diagram. I can pull it up too again if you need it. And I'm going to show, while I'm passing these things out, I'm going to bring up student D's work for the digital people. Okay, so the first thing I'm going to do is student D's work.
I think the cost of the renovation might be investment. So they might be like giving them something that costs them. We laugh.
It's a much older problem than I was. Just put across the ocean if you want it, I guess. Or the bay. Or taking a ferry ride or something. Right here. Awesome. Okay, so you can start looking at that. We're supposed to do what now with that? So, take your time to look at that in the student work analysis sheet, because these are what you're going to fill out for the other curriculars. I'll give you a few minutes to look at that one before I pass out the next one. So, if you're watching digitally, this is the student D's work. And here, let's zoom out a little bit. This is student D's work, and this is the student work analysis sheet that accompanies student D's work. Okay, I will go through this slowly and with more zoom right now. This is student D's work. This is the student work analysis sheet. And this is the blank student work analysis sheet I'm going to pass out. So if you're looking at home, you need to, at least on a sheet of paper, kind of write this stuff down. Okay, now I'm going to pass out students A, B, and C's work. Okay, if you're watching at home, that's student A's work. This is the other side of student A's work. Pause it if you need to look at detail at anything. And yeah, student B's work. Student B's work. Student C's work. Student C's work. Now I'm going to zoom in and go through them slowly again. Which is student A's work. Student B's work. Student C's work. So where we're at, just going through this activity. Remember, and if you're doing this at home digitally, keep your answers. Maybe you want to write a summary because I want you to write a summary of your thinking about these questions on the Facebook page when you do your post. And I'm going to go back to the timer. Well, you still have 32 minutes. If you're watching this digitally, when we finish with the 40-minute time that I set, and I'm going to keep the timer running. You're not going to hear any sound because I'm going to turn the sound off, but we're going to have a group discussion. So think about the things that you wrote down that you'd like to share on the Facebook page. It's also part of your quiz. Okay. Huh? How do you Kindle timer? Candle timer? Where's that? Here's church timer. All right. So well, let's. How about bomb countdown? Testing countdown. Okay, so I'm going to give 15 minutes for us to discuss what we're doing here. So let's go up. Okay, so what observations did you notice about the students' work that you'd like to share? About students A, B, and C. Any observations you'd like to share with the group? About their algebraic thinking. Remember, we're not trying to grade them or anything. We're just looking at their algebraic thought process as much as we can from their work. Obviously, grading, most of the time when we look at students' work, we're just grading it. We're not trying to see how they're thinking. Right? Or at least that's most of the time when I look at their work. Grading it rather than... But any thoughts on the 3 students' work? Yep.
Well, each time I took over the students student A took a lot of mental description, and they outline their thinking like that. That seems to be more of their mode of thinking, but they don't really use a lot of you may say representative and things like that, but they don't really try to write the algebraic sort of formal rules. And then student B still writes some descriptions, but they have more of the algebraic representations that we're used to seeing. And so they use more symbols. But then we also notice that student B not only uses symbols and some wording to support this, but then they also have different representations because they also have a picture on the back. And so we just felt like that was we have a lot of different things going on for student B. And then for student B, we noticed that they still it seems like maybe it's a student who possibly feels about like a student. It's hard to tell, but maybe that's a student who does a lot in their head. They touch the conversation sometimes, but they don't really write out very much about their thinking process.
Anyone else?
Just what she said.
Actually, Dr. Keck just said if you talk, if you come up towards the mic, then they can hear what you're saying. You can't change your mind, yours. Since this is being recorded, and some people they're not going to see you, don't worry. Yeah.
So, like she was saying on student A, you can tell that this person never really reached algebraic thinking as far as reaching like an equation for it, because whenever on number 3 asked, how would you work it out for 100 adults, they just said, okay. So they couldn't figure it out. For student B, we found out that they were their way of thinking was a little different, but they still didn't understand the algebra behind it, because you can see the formula on number 4 that they come up with 2a plus 2a plus 1. The 2a plus 2a, it was just they were kind of looking at it going that way and then coming back. So things. However, I feel like they got stuck. We talked about them getting stuck at number 5. They didn't know how to combine the like terms to come up with the ultimate equation, because they weren't able to answer number 6, which is working backwards. Like if you had this matrix, how many kids and how many adults were there? So they were almost there, but they didn't reach it. And like she said, on student C, their relationship, they were trying to make a connection that wasn't really there. They said on 3 that their role is to multiply the amount of adults by the amount of children. and then multiply by 2. So coincidentally, it did work for number 2 because that still gets the 4a plus 1. But whenever it got down to number 5, it didn't work, and you could tell it kind of stopped showing work. And once again, they didn't show number 6 either because they couldn't work backwards with it.
Anyone else?
Also on number 4, student C, mathematical notation. Because A times C equals AC times C. So they're trying to show what they're doing up here, but they're writing incorrect statements using symbols.
Anyone else? And if you talk, can you come up towards the, up here, I guess you're safe.
We thought the same thing at first, that the computations like AC equals AC times C was incorrect. However, if you look at his work up on number 2, it looks like he's doing 6 times 2 equals 12, and then that's his next step is times 2 equals 24, and then the next step is plus 1. So it seems like this student just doesn't, it's not that they're seeing all of those things are equivalent, it's like he's building onto the expression.
But saying that they're equivalent.
Oh, no, yeah, saying they're equivalent is incorrect. So it shows maybe some mathematical use to it, but we didn't take that necessarily as them meaning to say that they were equal. That was what I thought.
Anyone else? Or anyone from Marfa, you're welcome to interject anytime.
So one of the things that has come up here, can you hear us?
Did anyone notice anything else?
Yeah.
Like
Hello? Hello? Ah. Well,
or just share what you wrote down on the student work analysis.
Can you hear us now? Hello? Oh, good. Now what? Okay, so now I got to remember what it was you said. What did you say?
Student C has an equation, a mathematical representation of the problem, but if you're going to follow the pattern of their works from number 1 to number 3, it won't arrive for that.
Warren, we can't really hear what the person who's sharing is saying at this point.
So the issue was that student C had a mathematical, an algebraic or variable representation, but didn't appear to really be using that, especially I think in number 5, in the last part. And somebody there, I guess that last comment that you all had was an interpretation of that. Can you clarify what that was?
Yes, please. Or use your teacher voice, that's fine.
I have to preface this by saying that I don't know that my interpretation is necessarily correct, but that by the rule that they wrote in number 4, even though that's not mathematically correct, we all know that, but that when I compared that they're doing in number 4 to the process they're using in number 2, it appears that this student is not using equal signs appropriately. So it seems like this student is adding on to their answer from the previous step. So for instance, like the first part of number 2, they're saying 6 times 2 is 12, and then times 2 is 24, and then plus 1 is 25. So they're showing steps rather than equality. I don't know if that makes sense.
Did you have anything to share about that on your end?
But if you did that kind of computation,
Yeah.
you wouldn't have got the right answer.
It seems like the students got some muddled understanding of variables, and so it's hard to figure out how to apply that, what the student wrote down on the next question. So we're still kind of struggling with that, but we'll hash over that a little bit.
Sorry, I didn't mean to cut you off. Do you want to share now?
Oh, I was just saying, someone else said that student A never reached algebraic thinking, but I do believe that they reached algebraic thinking. They talk about the pattern, they know exactly how many times it repeats and how many times one. And the fact that they said okay over 100 is look, I mean, they kept saying it over and over and over and over, so I understand they said like, okay, we'll just pay attention to my next rule. If I know that there works 4 out of 100, well, watch what I do for A. It's going to repeat A minus 1 time, so for 100 it's been 99 times, so I do think it's a ratio. I mean, that's what I do for whatever it's about. Write it over and over and over, but I thought that was a little crazy.
So they actually did a verbal description of the algebra, right?
Yes.
They didn't write the formula down that we like to use, but they did write algebra just verbally. That's what you were saying. Anyone else like to share? Any other observations? And in fact, that's why they said they picked that work, is because it was algebraic thinking verbally, written verbally, not in an equation form, the typical way. And which of these papers seem the most like each other? The thinking. Is A and B the closest, B and C the closest, and A and C the closest? B and C. So one of our goals, and I guess I'll stop now since I don't see anyone else. Let me stop the timer. And one of our goals here is that we want to look at the way students think algebraically rather than just grading work or things like that. So I'm going to give you out one of the mathematical thinking record pages that you can write things that you want to remember from this morning. But we're going to take a lunch break in 10 minutes. So after lunch, we're going to do an activity, and we decided that you're going to write your solutions down individually and then pass them around the room and use your own work as student work to look at your algebraic thinking. So when we do the activity, without your name on it, of course, and we can pass them to different tables, and I can group them all up and then just pass them back out or something. Once you get your own work, you can kind of be in there. So we're going to look at your own work since we don't have student work at this point, but we will in February. We're going to look at your own work for the algebraic thinking behind it, right? And of course, since you all are teachers, your algebraic thinking might be a lot more advanced than your student work, but still, you can analyze your own algebraic thinking or your peers' algebraic thinking. No one's name will be on them. So. That's something to think about for this afternoon. We're going to do an activity. And we decided we're going to have to do it individually and then pass them around. So you can analyze them. Also analyze some more of the examples of student work as well in the same activity. All right, so I'll give you 10 minutes to jot down the things that you want to remember from this morning, and then we'll take a lunch break from 12 to 1 and come back at 1 and Think about more outside thinking. If you're watching this digitally, then this is what I'm having everyone do, so you can write them down yourself. You can take this time to write down a summary of how you thought about the student work for you to post on the Facebook page. Actually, All right, we're going to break for lunch and come back at 1. It's going to be a separate recording, so Warren, I'll send you the guest link when I create it.